Today we're going to be talking about shift in Javad JField software with the Javad Triumph LS. In this example, we have a project with known coordinates like state plane coordinates, and we're returning to the project and we want to set up our base on a remote location and then determine what the offset is from the basis coordinates to the true coordinates related to the project. And then we want to shift our work over to that and be able to work with those coordinates to be able to collect in that coordinate system. So what I've done is imported the DWG file and the ASCII file from the previous project. And with the Triumph 1M, we've set it up as a base for the Triumph LS as the rover. And we've started it with an autonomous position. So in our example, the first thing we're going to do is occupy one of the points with coordinates, one of our known points. But in reality, we don't have to do this. If you're in the field and it makes better sense to tie in a few new points that you don't know coordinates for, you can begin with that and then occupy the known point later and shift. And the shift is going to retroactively shift all those points before. So you could conceivably shoot points 1 through 9 and then shift on point 10. And then it's going to shift points 1 through 9 as well as 10, and then anything beyond 10. So a lot of flexibility with shift. You don't have to do this first, but that's how we're going to do it in our example. So there you see the DWG file on the map, and I'm going to approach the first known point. And then on the Triumph LS, I'm going to select the button marked point and switch it from point to shift. Now it asks for the known point. This is the coordinate of the point that we're occupying. I'm going to use the map to zoom in and select the point that I want, which is L114. And there we see L114 in the top, indicating that it's been selected. Now you notice that the button that was labeled point now says shift. At this point, we'll select start, and a notification pops up explaining that we're in this base shift mode. So we're occupying a known point, and we're going to calculate how far off the base is. So we press OK or continue, and we take our shot. Now for this, I'm going to occupy it for 3 minutes. And we've just about come to the end. And now we're ready to accept. I'm going to switch the code over to boundary. It's my own predefined code. And accept. Now it shows on the pop-up how much we're shifting in delta north, east, and up. And by hitting accept, we can accept this translation. Now, we should be within just a few feet of that shift. Remember, this is to be used for known coordinates and not to get onto an unknown coordinate system, a local coordinate system. That's what localization is for. This is simply to translate a minor amount, say from an autonomous position over to a known position. And so we see that those translation amounts are a couple of feet in north, a couple of feet in east, and about 10 feet in elevation. If it were a large amount, then that would be indicative that you've got a problem and that you need to revisit what coordinates you're translating to. After accepting, you'll notice that now we see an orange box at the bottom that says Shift Details, and you see that our point that we just collected is now right on top of that original coordinate. By pressing Shift Details at any time, you can see what those shift values were and see that the shift is applied. If you don't see that orange shift box, then it means that that shift is not being applied and you're still based on your autonomous position. Notice in the points list that both the base and that first point that we've shot have the shift icons there on the points list. As a final check, I would highly recommend that you do a stakeout to that original point, in this case L114, and we can see epoch by epoch that we're within 2 or 3 hundredths, so the shift did take place properly. And with that done, now we can proceed to our next point. So here we're occupying L115, and let's see how well we tie in after the base has been shifted. All right, at 182 seconds, our shot's complete, and we see we have a total distance of about 2 hundredths. So this could have just as easily been a collected point or something like that. In other words, you could continue working and expanding your collected points after doing this reverse shift. At the end, I'm going to go ahead and stop and download this base file. Now, it's only been running for a few minutes. Not really as much time as I would typically want for course processing, but we're going to just kind of show the workflow here. Notice that the icon says ML on the far right, indicating that the base is from a local shift. Also notice that the number of solutions for both points, there are 2, and that the base is still based on a standalone position, or originally based on a standalone position. So now it's a few hours later, and we're going to send this file to Dpose to process it. And because the base file is so small, I'm going to go ahead and do this in real time just to give those who may not have seen Dpose an opportunity to see just how fast and efficient this process is. So I've just simply pressed the Dpose button, and it's uploaded the base file and the 2 rover files to the Dpose server. It's processed the data between the base and the rover, and now it's processing between the base and the course. Now we should expect, if the previous work was good, that our offset should be fairly small between the course process base position and the shifted base position. And we'll get to compare those and see. But of course, again, that base file was fairly short, I think about 20 minutes long. So not really as much time for this particular area and the course spacing that we have here to really drill down to centimeter level positions, but we should have fixed solutions and have a fairly accurate position. All right, so the base has been processed to the course. Now it's applying that course processing. And it's done. So now we can go back to the points menu. And here we see that we have 3 solutions, and now the base has a CP. So the course position has overridden the shifted position. But that's okay, we can switch it back if we wanted to be back to our local position just by selecting the white circle there next to one local. Notice that our northing's about 22 hundredths, our easting's about 15 hundredths, and our elevation's about 3 hundredths. So again, it's not a great matchup, but it's not bad. Definitely tells us that we don't have a large blunder in our work. But I trust the coordinates established originally on that job, which were based on base session that was much longer. So I'm going to switch it back over to the local position and just rely on that CORS as a check. So this has been Shift in JField for the Triumph LS. It's a great utility and simple to use and really saves some time in the field.